Here's a set of very interesting questions which depict a real-life experiment. And in this video I want to give you sort of an idea how you tackle this problem. So obviously you carry out an experiment, you need to prepare a solution which is a 100 micromolar solution, and that would be considered as your stock solution. Stock solution. And in question 11 you calculate the dilution factor, and you should make up this 0.001 milligram per milliliter working solution. Working solution. Now in question 11 you calculate the dilution factor to get from the stock solution to this working solution, and in question 12 it basically says you have to make up 5.5 milliliter of 0.001 milligram per milliliter working solution from the 100 micromolar stock solution. Stock solution. And that is basically the task. Make up 5.5 milliliter of 0.001 milligram per milliliter working solution. How are we going to do that? Okay, so 5.5 milliliter of 0.001 milligram per milliliter from 100 micromolar solution. So what we can do actually is we can use C1V1 equals C2V2 solution, and we can say that here is our stock solution part, and that is our working solution part. So we have V1 equals C2V2 divided by C1, and that is here our concentration is 0.001 milligram per milliliter times the volume 5.5 milliliter divided by 100 micromolar solution. Now the big problem that we face here is that we have different units. We have milligram per milliliter here and we have micromolar here. So we have to really convert the 0.001 milligram per milliliter solution ideally into a molar solution, so into mole per liter, so that we have both in the denominator and in the numerator the same units. And let's assume the molecular weight of our peptide that we use is, let's say it's 500 gram per mole. So what we want to do is, the unit is mole per liter. That is what we want to have here. So we have 1 mole per 500 gram. times 0.001 milligram divided by 1 milliliter. Now the milli cancels out, the grams cancel out, and we have equals 0.001 mole divided by 500 liter. And this gives us 2 times 10 to the minus 6 mole per liter. So that is this one here, our 0.001 milligram per milliliter. That is the same as 2 times 10 to the minus 6 mole per liter. And what we can do now is we can write V1 equals 2 times 10 to the minus 6 mole per liter times 5.5 milliliter divided by 100 times 10 to the minus 6 mole per liter. And what we see is that the moles per liter cancel out, the 10 to the minus 6 cancel out, and we have our volume is 2 times 5.5 milliliter divided by 100, and that's 11 divided by 100, that is 0.11 milliliter. So we need 0.11 milliliter of the 100 micromolar stock solution to get 5.5 milliliter of 0.001 milligram per milliliter working solution. And we take these 0.11 milliliter and we have to add 5.5 milliliter minus 0.11 milliliter of buffer. So we have, this gives us 5.39 milliliter. So we have 0.11 milliliter stock and 5.39 milliliter of buffer to get the solution in question 12. Obviously, if you have a different molecular mass, you would have to take this into consideration, and your working solution would be slightly different. So you have to take that into consideration when you do this calculation here. So I hope this makes sense, and thank you very much for watching.